So in this slide, I'm going to explain the working of event loop and coroutines with the help of a simple animation. So you can consider this part as a task queue. So all coroutines that have to be executed will be added into the task queue, and this task queue will be accessible to event loop. So this part we explained previously. So event loop is having access to the task queue. So task queue having all coroutines that have to be managed or that have to be run simultaneously or concurrently with the help of this event loop. So how it is working? Event loop is actually looping through this task queue. So it is going to the first coroutine and executing the instructions. As soon as it is finding an await statement, control will be returned to the event loop and the event loop will move into the next coroutine. So it is again executing this coroutine, and this coroutine will be paused when it is finding an await statement. So coroutine will be paused and the control will be returned to event loop. Same here also. Here also it will go to the next coroutine, and as soon as it is finding the await statement, control will be paused here and control will be returned to the caller, the event loop. Then again it is going to the first coroutine, and control will be resumed from the point where it is paused last time. So it will execute from that point, and if it completed its execution, then control will come back again to event loop, uh, uh, and event loop is calling the next coroutine. Here also the coroutine will resume its execution from the last point of its execution. So it is control is paused last time, so it will be resumed from that point. And if it is not completed again, if an await statement is found, then it will again pause. This coroutine will again pause its execution from that point, and the control will be returned into the next instruction of event loop. From that next instruction, it will again call the next coroutine. It is basically a loop. So it is calling the next coroutine. This coroutine will also be executed from the last paused point. So execution will be resumed. And if it is again finding one another await, the control will go back here, and we know this coroutine is completed, so it will not consider that coroutine again the control will be going to this next coroutine, and so on. And once all coroutine is completed, the event loop don't have any coroutine to run more, so the control will be moving to the next instruction after the event loop. So this is how an event loop is managing concurrency using coroutines. So coroutines are actually working as a generator, and generator will be having a yield type of instruction that we already saw in the last slide. So this is event loop is actually handling multiple generators. So coroutine is actually a generator. So this is how the event loop is working. Uh, okay, so I am showing this animation here. So event loop is working like this continuously. It will be working like this. Finally, if all coroutines are completed, control will move to the next line. So if you are already clear about this event loop and coroutine, how event loop is handling multiple coroutines simultaneously. If you are already aware about these concepts, you can skip this slide. But here I am going to explain, or I am going to elaborate a little bit more about this coroutine. So that will make the working of event loop and coroutine, the architecture of event loop and coroutine more clear. So mm let me explain it here. As I already told, if you are already clear, then you can skip this slide. So let me elaborate. Let me go visually. Let me explain how it is working and all. So as I already told, um, as I already told, there will be having a task queue or coroutine queue. So all coroutines will be added into this task queue. So you can consider this area as the task queue area. Uh, so we are adding all the coroutines that should be managed simultaneously into that task queue. So once the task queue is populated, event loop will be having an access to event loop will be having an access to that task queue. So now let me explain how event loop is actually working. So we have three coroutines here, and each coroutines is added into our task queue, and the event loop is having access to the task queue. So it is having access to each of the coroutines inside the task queue. So first coroutine having this statements, second coroutine having these statements, and third coroutine is having this statements. So let us see visually how these coroutines are concurrently working, how event loop is managing this coroutine concurrently. So first this is an event loop. So this loop is starting. This loop is going to the first coroutine, and it is going to the first statement, and first statement is executed successfully, going to the second statement, that is also executed successfully, and the third statement, when it is reaching to the third statement, is an await statement. So when it is finding an await statement, it will pose the control here. So it is posing control here, and this one is completed successfully. As you know, this statement is completed successfully, but here control will be posed here, and after posing, what it will do, it is coming back and to the event loop. Then it is going to the next coroutine. So in next coroutine's first statement, so first statement of the next coroutine, the first statement of next coroutine, second coroutine, right? That coroutine is again an await. So it will be control will be posed here. It will be posed here again. Okay. So again, after that, control will be going back to the next statement of event loop, and it is going to the next coroutine. So it is reaching here and successfully completed, right? It is an ordinary statement. So since it is an ordinary statement, this one is successfully completed. This statement it will execute successfully. Then going to the next statement, it is again an await statement. So since it is an await statement, control will be posed here. Control will be posed here. Then again, um, it is returning to the event loop. So event loop fetch next coroutine. So it is a queue. So uh, the first coroutine control is going to this coroutine again, and it will resume from this point. So as you can see, this will be resumed from this point. So this is successfully executed. This line will be successfully executed. Then again, right, it is control is going to this statement. This is again an await. So again, control will be posed here. Control will be posed here, and the control. This is an await statement. So control have to be returned, and control will go to the next coroutine. So it is reaching. to the next statement after the await. So this actually reaching this statement, and this statement is a normal statement, so it is fine. Then it is going to the next statement. Again, it is one another await. So control have to be posted there. Control have to be posted there, and control is going to the control is again going back to the event loop, then going to next coroutine, and it is going to the next instruction after await. If this one is completed, right, it is checking this status here also. If this one is completed, then it will go into the next statement. So right, this statement is also completed, and uh, this statement sorry, so this statement is also completed, so this coroutine is actually completed. So it is marking this coroutine as completed, so it will be moved. This coroutine is popped out from the task queue. So this is completed actually. Once it is completed, it is going to event loop is going to and this coroutine again, and it is going checking the status of this data. If it is completed, right, then it is going to the next statement. So here um, this is also completed, and this coroutine is also completed because this entire statement is executed. So control is going back to this event loop and reaching to this one here, right. Here it is checking the await statement. What is the status of this coroutine? Is it completed or not? It will, if it is completed, the status will be completed. Then if it is completed, it will go to next statement, and it is it will be marked as done. Then it is going to next statement. It is also an ordinary statement, so it is also marked as done. Then uh, control is going back to this coroutine, and this coroutine all instructions are done, so we can mark it as done. Then control is going to this event loop, and there is no more coroutines available, so control is going to next statement after the event loop. So this is how the coroutine is actually working um, um, yeah, yeah, with the help of event loop. So I'm stopping this slide. I hope this slide is clear. It is explaining well the implementation of event loop. Um, so I'm jumping into the next slide. So once again, let me revisit one of our previous slide. So this slide was to explain the overall structure, code structure of um, coroutines and event loop. So this is a custom event loop. Um, I was writing my own event loop, simple event loop, just to explain it. And these two, worker one and this worker two, these are two coroutines. And these coroutines are added into the event loop. First, I am creating an event loop object. After that, adding worker one and worker two into the event loop, and I'm running the event loop. So this is the internal structure. This is just to explain the internal structure of a coroutine. And what is coroutine? That also I explained. So coroutine is actually internally generator only. So you can see the real generator implementation here. When you are calling an await statement, right? When you are calling an await statement, you are actually the await will invoke this await here, and it is actually they have a yield statement. So this function is converted into the generator, and that is why you can pose the operations and come back and execute from the next instructions. So um, when you are adding an async keyword, you are actually adding this section, right? These statements into this function object. So you can imagine something like that. So this is the basic structure of internal structure of a uh, event loop. So let me go to the next slide. So in the coding, um, normally what you will see in the normal coding is something like that. You will be uh, defining the coroutines like this, and asyncio, you will be importing asyncio that have a lot of third-party libraries also that support more enhanced features of event loop. So here you are actually invoking an event loop, and this is also a type of management of event loop also. But coding, I'm not going to explain more about the syntax, how to write coroutines and all. That I will explain in a separate session, separate series. I will explain how can you write more effective coroutines and all. But here I was explaining the internal architecture, how coroutines are working, how coroutines event loops are switching between coroutines and all. So here this is a revisit type of slide. So I am just explaining what is the structure of coroutine, and now when you are calling a coroutine, right here, when you are calling a coroutine, so now when you are calling an event loop, or when you are defining an event loop, here you can see when you are defining this syntax, async syntax in front of a function, then it is becoming a coroutine. So when you are defining a coroutine internally, you can see how it is converting. So this function, my function, you can see it is converting into a generator. So internally, when you are defining this type of a coroutine, uh, Python is actually converting it into a generator. So async is mapped into a generator, and this await will be mapped into yield. And this is one another coroutine. It should be one another coroutine. So this coroutine is also actually this is converted like this, yield from this coroutine, this generator. So it is checking the status frequently, is it completed or not when executing. So this is how it is mapped. When you are defining a coroutine like this, you can map it something like this. You are actually creating a generator with this name and yielding the result from one another generator, and resuming with the next instructions. And this is the event loop, how multiple coroutines will be there. So it will execute each statements, and if they have a yield, means this will stop right here, and after checking the status of the uh, inner level coroutines. So if it is not completed, control the control flow will switch to the next coroutine, and so on. So they have a relationship between the coroutine object and generator object internally. So with this last slide, I am going to wind up. I am going to complete this tutorial about Python's concurrency with the help of coroutines and event loop. So I already covered all the important topics related to event loop and coroutines. So the how it is working, how event loop is switching the control between the coroutines and all is explained already. So there is no much to explain in this slide. So here they have an task queue. So before event loop is started, you can add all of your coroutine to the task queue. So event loop will pop each of these tasks one by one, and it will execute the instructions inside the coroutines. And when it is finding a await statement, so it is waiting. That means you have to wait. The control have to wait for some result from some other coroutines. So await can only followed by one another coroutine. So control have to wait there, and um, the control is going to the next coroutine. So they have a something like multi-level type of um, hierarchy in coroutine. So from one coroutine, you are actually creating and invoking one another coroutine. And from that coroutine, you may be invoking some other coroutine. So that multi-level architecture is also there. So, but I hope this is enough. This single level of explanation is enough to understand the basic idea about the working of um, event loops and coroutines. But in the real time scenarios, they have a multi-level hierarchy of these coroutines. So in the first level, you will be having a set of coroutines added into the event loop, and from each of this event loop, you will be calling some other set of coroutine. So whenever you are using an await, you have to remember that you are calling one another coroutine from the current coroutine. So that multi-level architecture or that hierarchy is the tree type of hierarchy is the inside this coroutines. That also you have to keep in mind. So I think I already covered all uh, components or all design details of this concurrency or these coroutines in Python implementation. So that is enough from uh, uh, a developer side. It is enough to um, research more and understand more and to develop an efficient uh, more efficient concurrent type of application. So that's all from my side about coroutines, and yeah, thank you very much for watching.